Oh, hello everyone. I'm Xinkuan from Fujitsu Nanda Software Technology, and today I will discuss with you the topic of using wireless communication technology in AGL. Allow me to first make a self-introduction. My name is Xinkuan. What you see in the first line is the Chinese pinyin. So in order to help you pronounce it, I marked the English words below. The approximate pronunciation is similar to Nanjing Fujitsu. I'm working for Fujitsu Nanda Software Technology. You can see that I'm taking a photo with my company building in the picture on the right. The weather was very good. I'm a junior programmer. I work for the second development department of the Intelligent Vehicle Division. I've been involved into the development of AGL community for a year. In the past year, I'm one of the developers of the AGL extend test. So why am I setting such topic today? The cause of this thing is some time ago I lost my key to my car, and as a result it cost me a heavy loss. I paid $200 to Volkswagen, and the functions I got were simply as the following. You can look at the photo on my left. The first function is to lock my car, and the second function, if you look closely, you can see that it seems to be opening my tailbox. But it is not. It's just unlock the tailbox. The third function is to unlock my car. That's all. So I mainly have two questions. As a driver, I remember that at least 10 years ago that this kind of a wireless key already had these three functions. And so why after this many years still would we get this simple functions? And my second question is that is there more long-range point-to-point solutions for nowadays car key? Before talking about the solutions, I will analyze the essence of this car key. It is nothing but a wireless data transmission module. I personally guess that it is made of Zigbee. But because my key is too expensive, so I plan to disassemble it later. I think in about 10 years. At that time, I can buy my next one. So I would just go for the Bumblebee. I love Transformers. Bumblebee is my favorite. And I'll tear my key apart to prove that it is Zigbee inside. Anyway, we're using Zigbee to control Bumblebee. Anyway, they're all bees. So when I would be looking at the key on my hand at that time, assuming that this key in my hand at that time was still three functions like this, I couldn't help wondering why after all these years still these three functions. I know that modern cars are very powerful. They nearly can transform, but you need at least to be able to control them with the key you have. I know that the Bumblebee can be transformed, but when its owner can only control it through a simple key like lock and unlock the Bumblebee, open the Bumblebee's tailbox, I think Bumblebee is going to be aggressive. So I actually find that this kind of problem still exists on modern cars. So what do I wish to help with is, first of all, I hope that the owner of the car gets a gorgeous remote control that has more features than the original key on my hand. Secondly, I also wanted to try to establish a wireless connection between the cars as point-to-point. In this connection, there's no help from the cloud service. It's only just a private connection between the cars. Of course, since it comes to the topic of wireless communications, I also want to do some peculiar function. I'm not doing it for fun. It's just trying to make something that has never been there before. So what is specific? I will explain it in the following sections. Next, I will take a look at some of the researchers' papers in the field of wireless communications on cars. These papers are just exactly what we were investigating and setting this topic from. So researcher paper number 1, it's from the Journal of Computer and Information Technology. Their design and implementation is use of STM32 as the vehicle's ECU data collector, and integrated some GPS signal and the monitor device is gonna send these data to the cloud server wirelessly, and the host computer detected and showed it as the front side. I think this mode is quite common. Of course, I can still learn from it, but it's just too traditional to see any significant advantage. Anyway, I don't see any significant thing. I think you guys can see it. Please point it out. Too traditional. I'm going for the next one. Researcher paper number 2, which is a paper about the application of LoRa, or you can call it the full name, long-range radio. Well, the structure looks quite complex, but it is not of much different from the solution compared to paper number 1. But the development of LoRa allows to help the long point-to-point communications. You can see with the help of LoRa, we get a very long transmission range, but you must sacrifice the speed and transmission quality for that distance. I don't think that this research on long-range communications is quite helpful to our project, since we are going for more functions. LoRa itself cannot provide reliable connections. The transmission quality is quite worrying. Researchers' paper number 3, it is a report based on the STM32 motherboard, ZigBee coordinator as the extended devices. This solution here I will introduce ZigBee first. ZigBee is something we call bees. This is made of the coordinator bees, the end devices bees, and the router bees. It's like a hive. Router is some kind of device that lengthens the transmission distance. A coordinator is like the central control brain, and the end devices are equivalent to the responder, worker, and some data collectors. The whole control logic is similar to the hive, so we'll call it ZigBee. This author's work, the end device integrates a screen, a speaker, and a moving direction judgment clip. So when crossing the red light, the traffic light can send a signal to express whether it is allowed to pass or not. And the end device on the car will send an alarm message to the driver when it detects that the owner runs a red light. So if I change the end device and put the coordinator on the car, can it be understood as that I have added a variety of functions onto the car? For the cars, this kind of product solution can also be customized because each new node device, what we call end devices in ZigBee, once they are added, we only need to adapt it in the coordinator. Shall I make a demo with cloud in it? This is something to consider. With the cloud, you can get great web app, a whole bunch of various features that can help you control your car. But sometimes to do this kind of cloud demos are first unnecessary. Let's assume that I were just sitting behind the driver's seat. So why the first step is to the cloud? I mean, I can just connect to my car point to point with no help from the cloud. Second, it is sometimes impossible. Let's suppose that a car owner is now in the desert. There's no signal, but he's standing in front of his car. So may I ask, at this time, is it possible for him to connect to his car with the help of the cloud? Of course, I don't think so. I think he will be quite annoyed. Still, we are going to do some cloud demos using cloud service for some demonstration purpose, but it's a plan far away from now, and we will mention it later in the pages. My wireless communication research plan is roughly divided into 3 stages. The first period is to select the hardware and do some early developments. Because of involving the hardware, I may need to develop on the modules separately, and then I will integrate them into the whole system. The system would be able to be controlled by a multi-thread program. It's going to be written in C. At this stage, local area network application will be presented as the result of development period 1. The second period is demoing of the linked cars, which cannot be told clear in 1 sentence or 2. And it will be introduced in the following chapters. The third period is so-called calling my car demo. Because I saw that Vosk is already supported in AGL, and I have GPRS module. That module can provide some voice stream, so I thought I could try to make a demo of this, just calling my car. In the process of starting the first stage, I have to choose the hardware because this is a hardware-related project. So the base platform I choose is Raspberry Pi 4. And because Raspberry Pi 4 is easy to obtain and supported by the AGL system, and it has many interfaces, it's easy to add more extensional modules. So I will use serial communication to aid more external devices, which includes ZigBee coordinator and the GPRS module. In the monitoring camera section, you can choose your favorite USB camera. After completing the hardware selection, I will build a demo prototype. Considering that I am still working on an in-car local area network application, I will debug the cameras and the wireless modules to make sure that they work properly before the integration. The first development period goals are as follows. Make it AGL inside, of course. I need a local or web server inside, and I'm going to publish it through the 802.11ac clip on the Raspberry Pi, and it should provide basic UI that is going for the function menu. And command buttons on the function menu should be able to motivate the modules. Actually, I'm making something that's helping to get your phone as a remote control and a security monitor. The hardware structure of development period 1 is roughly shown in the figure below. A very small Raspberry Pi 4B has 4 USB interfaces, which means the wired connection can be one for the Zigbee coordinator, one for the GPRS alarm module, and one for the USB video camera. One is left. And the wireless transmission is built between the coordinator and the end devices. The software structure of period 1 is roughly shown in the figure below. The user can click on the front end, and the buttons will give data to the data processor on the Raspberry Pi, and the data processor is gonna translate those instructions and send signals to the extended hardware wireless modules. So we can see this demo is going to be a wireless connection to the AGL user, between the AGL user and the AGL vehicle. In the development period 2, I will make a demo which is called Link Cars. The overall concept is shown in the figure below. Assuming that 5 cars are driving on the avenue, and they establish wireless connections between each other, then it can be understood that these 5 cars are actually one. By the way, the wireless communication technology between them is likely to be Bluetooth. At least so far, no better choice has been found in the current investigation. Compared to a vehicle-to-cloud, this demo responds quickly, just like Windows operating system is slow compared to a real-time operating system. For cloud servers, there's no need for cars to shake hands with the server one by one, which is gonna help reducing the burden on the server side. Some private data will not be transmitted to the cloud, and in this way there are fewer security and privacy concerns, which is a little bit like decentralization in the field of vehicle-to-cloud area. And it's gonna be more environment friendly because a lot of calculations are reduced. In the Connect Cars demo, I will face some development difficulties. The first is the specific technology of wireless communication. I know that the working distance of Zigbee is too short and the speed of LoRa transmission is too slow, and I have no experience with other communication technologies. This mainly reflected in urban roads and on highways, because in city road, urban roads, we face short distance but quick handshake switch. But when it comes to highway, it's going to be long distance, so it's going to be a problem. Why this rational so what is the rationale for making this connection? If the wireless data message is sent directly, then the receiver will be difficult to determine the identity information of the sender. This kind of message lacks authentication and is unreliable. So in my design is to have a camera in front of the car and a camera behind the car. First, you read the other's license plate and then use the license plate information as an identity to confirm, and then establish a wireless data connection between each other. But there are still some questions. For example, some countries where license plates are not front and back placed, it's going to be a problem for them. The third period is calling my car. GPRS module can provide telephone service. Of course, you need to buy a SIM card from your local operator to use the service. AGL already has voice inside. Then after obtaining the audio data, the demo can respond to voice messages. So you can deploy voice recognition AI on AGL, and you can just simply call your car. For example, the Bond is calling, start the engine, and the data, it goes to the service provider. Of course, you have to pay them money, and they will offer you service. Later on, the message data is going to be transferred to the Bond's car, and Bond's car will say, yes, sir. In the short term, I will still focus on the implementation of period 1. And of course, I will do my best to provide complete documentation, and if it is required, I would probably provide some training videos on the Zigbee modules development and the GPRS module development. You guys can contact me through the community mailing list to join the project, or just send a personal email to my working email account. So thank you guys. That's all. Thanks for watching.